My name is David Robinson. I'm a program manager on the SQL Data Services team. Today we're going to talk about high throughput applications and tips and tricks and what you really need to do to get the most out of cloud-based applications and how to make them perform well. A couple things I'm going to start off with, some housekeeping. Number one, in my demos, there is a lot of moving parts. I was asked to not only represent SQL Data Services, but also to have my demos include all the other Azure services. So this is all live. This is all real. If anything hiccups, I apologize. I will try my best to dance around it and make it so that it's entertaining in some way, shape, or form for you. So that's number one. Number two is I'm originally from New York, and anybody who's heard me speak before, every so often, the F word just comes out, I just can't control it sometimes. I try to pull back a little bit, but if it does, I'm just going to apologize in advance. So let's get started. So how many times have you guys had like a crazy manager, crazy client, and they come up to you and they tell you, you know what, this is the kind of application we want you to develop. We want you to develop a news application, and it needs to have the following characteristics. It needs to be extremely scalable. It needs to be high performing, data intensive, low CapEx and OpEx. And also, your boss has been listening a little too much to Scott Goo, so it has to have Silverlight in it. It's one of the prerequisites. And then he drops a bomb on you and tells you, you know what, you have no hardware budget. What are you going to do? You don't have servers to test on, servers, no int environment, no production environments. You have no money. It's basically you and this laptop against the world. So what are you going to do? How are you going to actually go ahead and accomplish this? We got pointy-haired freak guy here, and he's going to get pissed if we can't do this. So let's talk about how we're going to go ahead and accomplish our mission and what we're going to talk about. We're going to talk about data modeling and partitioning, specifically with SSDS or SDS. I should have actually said that in the housekeeping. We just changed our name from SSDS to SDS. We dropped the S for savings. So I'm going to be saying SSDS probably all throughout the talk. I apologize. Marketing people watching me on video right now, I'm sorry. I am sorry. So it's SDS. So we're going to talk about data modeling and partitioning. We're going to talk about how we can process queries in parallel, to get more performance out of the system. We're also going to talk about concurrency. What happens if multiple users try to access the same cloud-based data at once? How do we handle that? We're also going to talk about utilizing a middle tier. Middle tiers are not new, but what is new is having a service platform to be able to host that tier for you up in the cloud. And then we're going to talk about support for batch processing, how we can enable this in our scenario. And obviously, the theme of this week is Windows Azure. I got to tell you, when I was told, you need to use .NET services and you need to use Red Dog, I was like, oh, right, I'm excited. This is great stuff. I get to use all this new stuff. And I walk out of the meeting, I'm like, God damn it. It's something new I got to learn. It's going to be a pain in the butt. I got to tell you, and yes, I might drink a little too much of the Microsoft Kool-Aid, but this stuff, it's easy to use. It's phenomenal. So when you guys take a step back a week from now and you're playing with your test accounts and whatnot, it's just phenomenal. I kid you not. This is great, great, great stuff. So let's continue. So let's quickly talk about that animation is not working. Somebody played with my deck. Okay, so let's talk about quickly what's known as the ACE concepts, this beautiful looking slide as you can see up here. We have something known as the ACE concepts. This is the data model. This is the way you model data inside SQL Data Services. ACE stands for has three meanings. A is for authority, C is for container, and E is for entity. It's a little hard to without the slide up there for you guys to visualize this, but think about an authority being a service endpoint up in the sky. So when you go out to SDS and you actually say, listen, give me an account, you get an authority. That authority is a unit of geolocation and a unit of billing. So what we do is we actually give you a DNS name for that. So for instance, all my demos, my authority name is davedemo.data.database.windows.net. So when you go out and you create an authority, you're going to get a similar DNS name. Container, which should be the middle area of this imaginary slide, consider a container like a database. So containers contain entities, which would be the area at the bottom of the invisible slide. So entities are the actual units of data inside the system. So think of entities as rows inside of a database. So let's move forward. So let's talk about data modeling inside of our application. So when you're modeling data with SDS versus a typical SQL or Oracle, any other relational database, it's not that different. So one of the things I like to do when I'm creating an application is I like to take my data and I like to group it up into buckets. I have one bucket that's like static data. This is data that's never going to change. This is data I'm going to probably cache the hell out of. Stuff that it's good stuff. Then in the middle, I have this data that doesn't change very often. It's kind of like static data, user profiles. How often does somebody actually change that profile? And on the right-hand side, I have the data that's going to change all the time, this highly changing data. And for instance, in our application, since we're doing news postings, it's going to be the content and the wikis and the comments and any user-to-user interactions we might have inside the system. Who's playing with my deck? So one of the additional things that our application requires is more advanced relational features. Things like joins, things like top, things like order by. That should actually say take. I got to apologize to you guys. This slide deck is not the current slide deck, so I apologize. So if we take a look at our different entities inside of our system, we have a posting entity, a comment entity, a tags entity, and a rating entity. So like we said before, we had the ACE concept, so we had the authority, the container, and the entity. And these are different entity kinds inside our container. And now with the latest release of this Sprint 5 bits, we're actually able to take these entities and we actually can join them together. So it's a pretty phenomenal thing. And bonus, one thing that I don't think we do a very good job of telling, and I like to really stress it, is that when you create an entity inside the system, every single field is indexed automatically. So any DBAs in the room are probably like, oh my God, what do you mean that's so much overhead and whatnot? We have done lots of work to make sure that this is fast and this is streamlined. So bonus, don't worry about having to say what my primary key is going to be, what my index is going to be, and so on. So this is a familiar join inside SQL. Excuse me. I might do something like select P from posting tag from tag, and I do a join, and then I say show me all tags that have the word strata inside them. It's not that different inside SQL Data Services. It's what we use is the C# link syntax, and this is what the same query inside of SDS would look like. Once again, this slide is out of date. I'm not going to say it anymore, but there's some syntactical errors inside this slide. They will be posting the updated slide to the PDC site, and I'll also put a copy of the corrected slide deck on my blog as well. But as you can see here, it's very similar. Yes, it's a new syntax, yes, it's something new to learn, but it's not all that different. A lot of the same topics that you're used to using inside of a relational model, apply to SQL Data Services. So, how are we going to go ahead and model and partition our data? So let's take a quick look here. So we have, if we took a look at the architecture of SQL Data Services, and we have a good talk coming up later on today and also on Thursday that goes into some of the really deep, architectural nuances of SQL Data Services. But if we take a look, we could see that all the containers are scoped to individual back-end nodes inside the system. So if you were doing something on-premise, you might have one server, you might have a bunch of servers clustered together. we have hundreds and hundreds and hundreds of servers sitting there waiting to service your requirements. So one thing to keep in mind is that containers are scoped to those nodes. General rule of thumb is spread your data out across multiple containers will give you the best performance. So instead of having a single server work on your requests, you're going to have many, many, many different ones. So how are we going to go ahead and model our data for our application? So we said we were going to have basically 3 buckets of data. We were going to have static data, data that changes, every so often, and then data that changes constantly. So based upon what we just said, we're going to devote one single container towards our static data. We're going to devote 36 containers towards our user data, and all the remaining containers inside of our system, we're going to devote to our application data. This is the data that's going to change constantly. We want to maximize the amount of containers that we're able to hit for this data. So we just very quickly talked about data modeling and partitioning. I know this is supposed to be an advanced talk, but it's a little difficult giving an advanced talk with, with topics that, is new to that are new to a lot of people. So we just covered, a brief overview of the data modeling and how to partition our data. So what's next? Parallel query processing. So let's take a look about that. So how actually, when you go ahead and you issue a query inside SQL Data Services, how does that query actually get processed? We spoke a little while ago how we had many, many different back-end servers where our containers are scoped to. We also have a great deal of front-end servers. So once again, just like we said, use many, many containers to get the best performance. Try to take your queries and try to process them in parallel so you can get the best performance out of all the multiple front-end servers that are available to you inside SQL Data Services. So once again, the general rule of thumb is process your queries in parallel. Will give you the best performance. So let's just jump out and do the first demo of the day, which is this machine. OK. So what do we have here? We have just a pretty basic dummy application here. So if we take a look, we have a text box that says first name. We have a slider that goes between 1 and 50. And so let's go ahead and type in somebody's name. And I believe Jacob is a good name to use. I believe. So it's going out there, and it's going out there, and it's finding no Jacobs. Let's just run this one more time. Joshua. Let's run this again. And it's not finding Joshua either. Interesting. Strike 1 on the demos. OK, so once again, we're having some sort of slight issue. Basically, let's talk about this for a second, what actually should be happening. So when we actually issued our query, remember a little while ago we had a slide up that said we were going to have 36 containers to hold our user data? The reason we chose 36 containers is that actually in our application, we use Windows Live IDs to actually authenticate people in the application. Windows Live IDs, if you look at the actual ID and the token that you get passed back, it's actually a GUID. So we're actually taking the first character of the GUID and we're spreading it out across those 36 containers. That's how we're going ahead and partitioning our data. So what this demo was intended to show, if it was working, would show that if I issued a query for Joshua and it spawned out that query across all 36 containers, it would have come back probably in about 10 seconds with one single thread. But you would notice as I bump the number of threads up, and now I'm taking my query and I'm targeting multiple machines, and I have all these different front ends servicing these requests in parallel, you're going to start to see the numbers go down. So at 36 threads, which is the maximum I can really do because there's only 36 containers, we would actually see about 5,000 records come back in 1.2, 1.3 seconds. I encourage everybody to stop by the Strata Lounge, and we can actually run the stuff live. But I apologize about that. Let's move forward. So what did we just learn? We talked about how SQL Data Services operations are processed by these front-end servers. And then we also said for best performance, multi-thread your calls, and take advantage of those many front-end servers. So quickly, let's just regroup for a second. We talked about data modeling. We talked about parallel query processing. Let's talk about concurrency. Excuse me. So, what happens if we have multiple updates to a single entity inside SQL Data Services? SQL Data Services provides immediate consistency. I'm not going to get into cap conjecture here. This is not, that kind of talk. But just keep in mind that when you do an insert, when you do an update, it's immediate. It's not, okay, let me try again to see if I got the most current record. Immediate. So let's consider what happens when multiple users try to access the same or update the same record. So let's say we have posting number 1, 2, 3, and it's been viewed 134 times. We have user A, user B. They look like twins to me. And they do a view count plus plus. And they both go ahead and try to update that. So how do you handle that? Well, it's pretty easy in SQL Data Services. So if we look at, for those in the house that are familiar with SOAP, that's the actual syntax for handling it inside SOAP. Basically, we use a property called version match. And we say that, OK, so here is the version I have. I have version 1.3.4. And I only want you to perform this update if the version that you have, you being SQL Data Services, only perform this update if this version matches the one that you have. Similarly, in REST, same thing. In this case, we use the HTTP header of if match. Same basic syntax. I have 134. If it matches, go ahead and perform the update. Pretty easy stuff. So what are the takeaways for actually talking about concurrency? OK, so SDS provides immediate consistency. Make sure that you use an appropriate version of semantics. So you don't want multiple people updating the same data and then things become out of sync. That's the purpose of a relational database. And now that SQL Data Services, which is powered by a SQL Server, is being moved up to the cloud, these are things that you got to keep in mind. Once again, SOAP use the match type property, and REST use the if match header. 106. So we talked about concurrency. Let's talk about caching in our middle tier, because we can't forget that using a middle tier is nothing new, but once again, we have no hardware budget, so we have to somehow find some place to host our middle tier. So let's talk about, for a second, quickly, Windows Azure Service Hosting. So let's come out here, and let's open this up. Let's go here. OK, so I got a pretty big project here. This project is pretty much all the demos and all the moving pieces of my presentation. Inside this, I have a web service, actually 2 web services. One is a SOAP web service, one is a REST web service, which you can actually see right here. I can very easily run this on my laptop, and I can run it, and it'll run either IIS or what have you. But the whole point behind all this is, how difficult is it to take this and host this up in Red Dog? Now, once again, I was the skeptic. I was the guy walking out of the meeting saying, oh, crap, I got to learn something new. This is going to be a pain in the ass. I tell you, all you need to do, and once again, I'm with the SDS team. I'm not trying to, tell you best practices for for service hosting and whatnot, but
Red Dog Azure? What is Red Dog?
Red Dog is one of the internal code names for one of the Azure products.
Okay, so just think Azure when you say Red Dog.
Yeah. Okay. So if we look here, I've lost it. I've lost it. I can't find it. OK, so right here, if we look here, let's take a look at this for a second. All I needed to do to take my web service and host it up inside the Azure service platform was create basically this little text file. And what this text file says is it goes out there and it initializes some environment settings. And it runs this command called cspack, and it runs this command called csrun. Basically, the package is going to package up the web service. Csrun is going to take it, and it's going to push it up to to the service platform. So let's go ahead and open this up and see what happens here. I'm going to open that up with command prompt. I'm going to run red door pack and run. And we're going to go ahead and the demo gods, this is strike 2. Look at this. I'm doing great today. What's going on here? It's launching Developer Fabric. Let's see if it comes up. Got to keep your fingers crossed, guys. Come on. So basically what it's doing is I'm using the local Developer Fabric. Has anybody been able to download any of the Azure products yet? Yes, no? So you'll notice that it comes with this really, really cool, kind of like a one box, kind of like a host your own development system so that you can test locally and then go ahead and upload that. The desired results would have been to take my web service and actually go ahead and load it up in here, but something's going on and the gods are not too happy with me today, so once again, we're going to move on from this one. That's strike 2. Do I get to go home after strike 3? Very good. So let's go ahead and go back to the PowerPoint. So we saw very vibrantly how easy it is to host things inside the Azure Service Platform. Let's move forward. So once again, it's really nothing new to learn to host your services up in Windows Azure. By using Windows Azure, your middle tier is located close to your data. So that's one of the things you got to keep in mind, that there is a certain amount of latency, a certain amount of thought that you need to put into developing your cloud-based applications. Your data is no longer 8 milliseconds away. So by having your data tier hosted up in Azure, it's in the same data center as your SDS data is. So it's very, very quick. Could we hold all questions to the end just because it's a lunch session? It's only 45 minutes, and if we run over, we can always do questions back at the lounge. I apologize. So we talked about caching in our middle tier. We've also talked about the data models. We've talked about how to process our queries in parallel. We've talked about, hey, what happens if multiple concurrent updates happen at a single time? Let's talk about batch processing for a second. So this is one of the requirements that we were given by our fearless leader. After someone creates a certain type of posting, we're going to have to go ahead and do additional processing before we actually go ahead and make that live. Once again, this is easily handled with .NET services. So imagine this for a second. We have somebody creating a new posting, and it loads it up to SDS. What we actually have done inside our application is we were actually using a .NET Service Bus. We're dropping a message on the Service Bus, and it's sending a message off to some other application that's going to actually take our posting, do some additional processing on it, and then go ahead and take that, fetch the posting. He's going to do the additional processing on it, and it's going to go ahead and it's going to update SDS again. So this is a great way with .NET Services to go ahead and do these types of things. We actually were going to have a demo of .NET Services at this point that was having some technical difficulties this morning, so we actually pulled it. Once again, stop by the Azure Lounge, and we can actually go into detail on some of these demos. Once again, the key takeaways for batch processing are large, complex applications. They can really benefit from offline batch processing. Anybody in the room that's ever worked with COBOL and worked with Kix and some of those older mainframe languages, there's things that but our forefathers did, in data processing that still has some relevancy today. Things like batch processing. .NET Service Bus is a great way to go ahead and handle that offline processing. So we talked about that. So basically, we've covered all the different items in our agenda. Our mission's accomplished. So with all these tips and tricks, what kind of an application can we build? So let's quickly jump out and pray that we don't get a strike 3 on our last demo. And let's go out here. Oh, wrong machine. So some of you might have seen me earlier in the week walking around the convention center with a backpack on. That backpack was not just any ordinary backpack. That was a super backpack. So inside that backpack was this laptop. That backpack is actually sitting down here somewhere. It was actually outfitted with a bunch of different fans to actually keep that backpack cool. So this is one of the demo applications, and so there we are. We're in the Los Angeles Convention Center. There was supposed to be an aspect of this that would actually take our geolocation data and actually geotag the videos that we're about to take. But unfortunately, the convention center must be made of kryptonite or something, because I've been unable to, anywhere in this convention center, holding the GPS up against the glass to get any sort of signal here. So let's go ahead and start our video preview. Give it a second. Is this on? Let's try this one more time. Man, I am just dying up here today. Maybe this has been on for too long, but it's not happy with me. Cable in, camera on. One more time. There we go, that's better. So, it is just not happy today. Okay. So let's talk about this for a second. Good, I got my dancing shoes on, guys. So, basically, what this application, and I promise all of you, if you come to the Strata Lounge and we disconnect it from this projector, all the stuff's going to work. So basically, what was going to happen is we were actually going to take some video. That video was actually going to be taken and streamed up to SQL Data Services. If the GPS gods were looking down upon us, the GPS coordinates would have been actually tagged to it. At that point, I was then going to close out of here. It wasn't going to throw this exception. And then I was going to show you this. So what we've actually done is we've actually taken pieces of the Channel 9 application. We've recreated it in Silverlight. It's running against SQL Data Services as its back end, and it's using Windows Live Services as its authentication menu. So this is actually all the stuff happening in the background. It's actually loading up all the different videos. Here's an actual video of Nigel Ellis, one of our team members. You know, I had the video camera turned on. I didn't know it, and it just started recording video and whatnot. So this was it. This was supposed to be the crescendo of the demo. You know, to be able to show the video, to be able to show, you know, how the advanced query processing capabilities of SQL Data Services combined with the power of the Azure platform is able to produce some really, really phenomenal applications. So once again, demos didn't go as well as they did. I'm going to open it up now for questions. I really ask everybody to stop back at the lounge and actually let's see some of this stuff work. Let's step through the code, you know, and let's have some fun. There's actually a microphone set up. I'm going to ask everybody to just walk onto the microphone because it's being recorded for the folks at home.
Container.
Can we get the mics turned on?
The container architecture that you described sounds
Yes, sir.
interesting. That's what I want to find out about. I really didn't understand what you were saying about having 36 containers for each character
character of the GUID?
Okay, so if we look at a GUID, we look at the first character of the GUID. So the question was, how do these 36 containers relate to the GUID that people use as a Windows Live ID? So if we look at a GUID is made up of the numbers, the first character is made up of the numbers 0 through 9 and A through Z. So that's actually 36 combinations. So what we do when we store users is we actually look at the first one, and that's what we use as our partitioning key. So based upon the first character of the Windows Live ID, that's what we use to say, okay, it's going to go into the A users container or the B users container and whatnot.
Containers separate different users. There's X number of users in each container.
Correct.
It's a hashing.
Exactly. And if we actually look out here, no, the first character. So it's A through Z plus 0 through 9. So it's the 26 characters plus. Here, let's take a look here. Okay.
Is it hex or not?
It is hex.
So that's 8 through half, 0 through 9.
Okay, hold on.
But the basic concept.
Yes, I think you understand the basic concept.
So you were just saying you separate into containers, because then when you have a particular, see what we're doing query on Joshua. Is Joshua map what you live ID?
So what Joshua did, what that demo was intended to show, was that inside all these different containers, we loaded up a large amount of people. There was actually about 4,000 Joshuas out there spread amongst all these different containers.
Okay. And so you were issuing a different query. What did each of your threads, what was each of your queries doing?
It was doing a search for Joshua in a particular container.
Okay.
It was then pulling all the results back, aggregating them, and showing you the count.
So you say, give me this URL, I want to query all Joshuas in the container 0, in the container 1.
Exactly. Mm-hmm. Sir?
You mentioned using caching, actually using Azure to cache your data in the middle tier, and that will give you the locality with the data. How do you ensure that where you actually have your service running in the cloud is actually local to or close to your data?
So when you actually, at the time when this stuff goes live, you're actually going to be able to choose the data center in which SDS runs in. So for instance, if the majority of your customers are on the East Coast, you're going to want to choose an East Coast data center. That way it's located geographically close, so it has less hops to make to your users.
Okay. And just one more.
Absolutely.
You mentioned that the container is scoped to a particular node.
Correct.
Does that imply any specific limitation on the amount of storage you can have within a container?
Not at all. So we have some algorithms that actually make sure that all the load is spread out across all the different back-end nodes inside the system. So there are certain limitations inside the system, certain quotas that we've enforced. And most of those quotas is just there to make sure that we're able to back up and restore data in a timely fashion. And also to kind of force people to think about partitioning their data and how they go about doing it.
Okay. All right. Thank you.
I had two questions about the early part of your talk. So one was you were saying put your read-only data, your system data somewhere. Well, often that might be joined with other data, right? Because it's reference tables and stuff. So what is that like? I mean, it's in a different container.
Yeah, so we do not support cross-container joins today.
That wouldn't work, right? I mean,
so that wouldn't work. So what you would need to do is you'd need to pull back. If you were joining this reference data with some other live data, you'd have to pull it back to your middle tier and actually do the aggregation there.
okay. And you would also need, if you needed to do joins against some of the live data, you would need to replicate, or you could replicate the reference information if it wasn't much
absolutely.
in each of those 36 containers. But you have to be aware of which partition you're, in other words, when you're writing your code, you have to be aware of the how you partition the data.
Oh, absolutely. Yeah, so that's one of the things that when you start to think about how you're going to design your application, you have to really think about your data model. So you need to understand how, how you're going to lay out your containers and how you're going to model your data.
Do you have anything that shows a data model? I mean, you didn't show anything there, right? You just...
We can actually, if you stop back by the lounge, we can actually pull up and view all the different containers and whatnot, and we can actually, talk in a little more depth about it. Any other questions? Going once? Twice? Enjoy the rest of your day, guys.